Welcome to qnawire.
Okay, so we have the following aldol product. It's an aldol product because it contains an aldehyde moiety as well as an alcohol. And as we know, aldol products were formed via the combination of a carbonyl electrophile and an enolate nucleophile. And so our job here is to determine what those two components were. Note that the way we want to solve these problems is to find the alpha carbon and the beta carbon of the carbonyl, and then consider splitting that bond. And then we redraw the portion of the molecule which contains the alpha carbon, and as instructed, we want to show the enolate form of this nucleophile, wherein we put a lone pair and negative charge on the alpha carbon, right? That's the carbanion form of an enolate. With the other half of the molecule, right? So this is our nucleophile. The carbonyl electrophile. What we need to notice is that this hydroxyl is in fact the oxygen, which was previously the carbonyl or the carbon-oxygen double bond. So we essentially just redraw the right-hand side of the molecule, that which contains the beta carbon, but as either an aldehyde or a ketone, depending on the substitution of the carbon with the carbonyl. So we redraw the carbon skeleton, but where previously we had a hydroxyl, we would draw a double bond to oxygen. And in this case, it's an aldehyde, so we can draw that extra hydrogen. And so the idea here is that this was formed through this carbanion attacking the carbonyl carbon, the double bond going up onto oxygen to form an alkoxide, and then being protonated in a later step to give us, in 2 steps, the product that we were shown. So then our final answers would be that on the left here is our enolate nucleophile, and on the right, our carbonyl electrophile. So it's always as simple as that. Split the alpha beta carbon bond, and then redraw the left and right hand portions, or the alpha and beta portions, so to speak, as demonstrated.